Okay, so in this video, guys, we're going to be looking at how to sketch exponential graphs. We've already looked at how to solve these things. Go look at that video. We're going to sketch them now. Now, an exponential graph, remember, is a one-to-one function of the form that there, where a is the base. This is the base of the equation at little a, and all the other things, a, b, c, and d, are all transformations. This a at the front, this a is a dilation factor from y-axis, or x-axis, sorry, that affects the y value, and it can also be a reflection. If it's negative, that'll be a reflection in the x-axis. This b here, that one is a dilation factor of 1 over b from the y-axis. And it's a reflection, if negative, it's a reflection around or in the y-axis. The value of d here, that's your vertical translation. It's also your horizontal asymptote that appears, and we can see that in our graph down here. And to find the horizontal translation, we take bx plus c and solve to find the horizontal translation. Okay, so if it comes up being negative, x equals negative something, it's a -3, it's going left. If it comes x being positive something, it's going to the right. That's really important. The simple shape for us is this curve here. Remember, if we're doing 2 to the power of, it means we're doubling every single time. And so forth. It all depends on what the base is, how fast it goes. So the bigger the base, the steeper it climbs. The smaller the base, the shallower it is. If the base is between 0 and 1, though, it'll go the other way. The maximal domain of these things is all real values, and the range, if this value of a at the front is positive, the range is everything above the asymptote. If this a is negative, it's everything below the asymptote, which is why I have these two options for you down here. So let's have a go at sketching these things. I'm going to state the domain and range as well for each one. So, first of all, the easy one is always to find your horizontal asymptote. That's this thing. All right, so we're going to put a horizontal line at y equals -6 down here. Whoops. It needs to be nice and straight. You use a ruler, of course, if you're doing this on an exam. Y equals -6 goes down there. We're going to find our y-intercept by letting x equals 0. So f of 0 is 2 times 3 to the power of 0 minus 6. 3 to the 0 is 1. 2 times 1 is 2. Minus 6 is -4. So you have an intercept there at 0, -4. Now, all the a and b's are positive. So you got this is a positive at the front. So the graph is going to go some kind of shape. Whoops. The shape from down here. It's going to go through there. We've got to work out where it goes through at the x-axis there, and that is where we find the y-intercept. So y-intercept, you have 2 times 3 to the x minus 6. Add 6 and divide by 2 in that order, and we get that. Therefore, x equals 1. So we have an x-intercept at 1, 0 there. And then we're going to join those dots. As always, it's not a bad thing to try to get some accuracy in here. So if I want to find out what the y values of x equals 2, I'm going to put x equals 2 in my equation. So I get 3 squared, which is 9, double it's 18, take away 6 would give you 12. Now each of these gaps are 2, so 2, 4, 6, 8, 10 should be sort of going through up there somewhere is the idea. So we want to make sure we can come from nice and low in here and then go up through a coordinate there and then up something like that. as best possible. That's our first one. You wouldn't have to go off the edge of the graph. I was just doing that in this case to help me to follow the scale that I've drawn. I can stop there. Next one. First thing always is find your horizontal asymptote. Nice and easy. It's one sitting at the end there. We're going to go with y equals 3. In this case, it's not very big, so we can just go one box for 1 unit. There's y equals 3 there. We're going to find the y-intercept now. So g of 0 equals -3 times 2 to the 0 plus 1 plus 3. Now 2 to the 0 is 0, 2 to the 1 is 2, -3 times 2 is -6 plus 3, and those things give us -3. So the y-intercept is all the way down here. And last of all, let's then find our x-intercept, which must be over here somewhere. Because you look at the graph, it's negative, so it's going to be upside down, which is fine. So it's going to be doing this because it's negative like that. And it's positive in front of the x, so it must be coming this kind of direction and going down through there. So let's find the x-intercept. We know it must be negative somewhere, so hopefully we do things right. We come out with the correct answer. We get -3 times 2 to the x plus 1 plus 3 like that. Subtract 3. You get -3 divided by -3 is 1. Now, 2 to the power of 0 is the same as 1. So you end up, therefore, x plus 1 equals 0, giving us an intercept of -1, which is there. So -1, 0. And now we're going to, again, try to be as accurate as we can. And we're going to not draw it like that. Drawing graphs on videos are a little bit fraught with danger because they're not as easy to draw as on a whiteboard, but we'll try again. Something like that. My students would tell me I lose 512 marks for that, but that's the general gist of it. I'll try one more time. Much better. Going through there, and this one should be heading towards the asymptote, not away from it. Okay, last one. This time we're going to sketch this graph. I actually haven't stated the range for each one yet in domain. I have to come back and do that in a minute. But I have a positive one there. Like that. And that's my horizontal asymptote there. That's done. Make sure you always label that. And then I'm going to look at my y-intercept. So h of 0 times 3 to the -2 times 0 plus 1. Add another 1. Now 2 times 0 is gone, so 3 to the 1. So it gives you 3 halves plus 1, which is 5 over 2, which is 2.5, which is there. 0, 5 over 2. And in this case, the graph is going to go that way. Now it's going to go that way because of this negative in front of the x. Remember that negative reflects it around the y-axis. So it's going top left to bottom right. The other thing we got this time is a negative. Oh, and I know it's up here like this because we're at the positive 1/2. So there's going to be no x-intercepts in this case. The other piece of information is this idea of an endpoint we've introduced this time. So what I want to do, I want to find the value of the endpoint. So we have 1/2 times 3 to the power of -2 bracket -1 plus 1. We're going to simplify this. So 1/2 -2 times -1 is 2 plus 1 is 3. So 3 to the 3 plus 1, and you're going to end up with 27 over 2 plus 1, which gives you 29 over 2, which we know is 14.5. So now that I've gone and drawn these things, I'm going to get rid of them because they're not going to fit with our scale. So I'm going to make each one of these, it's 14.5, each one of these is going to be worth 3. So that way here at -1, we can plot our point at -1, 29/2 is going to go there. We're going to come through, that's 3 there, so 2.5 is going to be pretty close to 3, so 0, 5/2, and we're going to have horizontal asymptote running along at y = 1 here. And then we're going to join our dots going through here again. So we're going to come down, it's going to be pretty steep, come down through there, and then head down towards our asymptote there. That's how we draw our graphs. Now, the last thing we need to do is go and find these domain and ranges for each graph. Now, in this case, I haven't actually written them out, but I should have, because the question asked me to. So in this case, we've got domain. Now, no domain is given, so it's the maximal domain. The range we can see is bigger than -6. So -6 the asymptote, it's all above it. This next one, domain. Again, it's not limited, so it's all real values. And the range, therefore, is also its maximum range, which is going to be y is less than 3, because the asymptote's here. Everything below it gives you y less than 3. This final one, however, we can see there is a restriction. The domain is x is bigger than or equal to -1, or you could write it as -1 to infinity if you wanted to. Either one's fine. The range is also restricted, therefore. So the range, you can see, it goes down towards 1, so it's going to be bigger than 1, but it goes up to and includes, but goes no further than 29/2 like that. So normally these things are just bigger or less than the asymptote, but with a restricted domain, you get a restricted range as well. And that is sketching exponential equations as well as finding domain and range.